Okay, so let's dive into a project that's using some seriously smart tech to tackle a huge global problem. This is RecycleBot. And at its core, it's all about bridging that gap between what an AI can see and what a robot can physically do, all to help build a more sustainable planet. And this quote right here, it just perfectly sets the stage. It gets right to the heart of the problem, the major bottleneck in recycling efforts all over the world. The fact is, we generate waste way faster than we can sort it, and the old school manual methods just can't keep up. That's exactly the problem RecycleBot was designed to solve. So why is sorting such a massive hurdle? And maybe more importantly, why is automation the key to what we call a circular economy? You know, that idea where we reuse and recycle materials instead of just making more trash.
I mean, the challenges here are pretty staggering. Our recycling systems are just completely overwhelmed with plastic. The manual sorting that's currently done is not only slow and inefficient, but it can also be really hazardous for the people doing it. And without a scalable automated solution, that whole vision of a true circular economy where our waste becomes a resource is just gonna stay out of reach.
Which, of course, brings us to the solution. So let's get into it and break down what RecycleBot actually is and how it's built to take on these challenges with this really cool mix of artificial intelligence and robotics. I really love this diagram because it takes a super complex system and makes it incredibly simple to understand. You've got the input, right? A stream of mixed up waste. Then you have the eyes. That's an Intel RealSense camera, which sees everything. The brain is a powerful AI model that figures out what each object is. And then you've got the muscle, a super precise robotic arm that does all the heavy lifting, creating a clean, sorted output. It's just brilliant. Now let's peek under the hood at the actual tech making this all happen. On the hardware side, you have that Intel RealSense depth camera for vision and a 60OF robotic arm. That 60OF just means it has 6 axes of movement, which gives it incredible dexterity, kind of like a human arm. Then, the software side is powered by the YOLO 11 model, a really powerful object detection AI, and it's all stitched together with Python scripts that basically act as the system's central nervous system. So we know all the parts, but how do they actually work together in harmony? Let's follow the entire journey of, say, a single plastic bottle, from the moment the camera sees it to the instant the arm drops it in the right bin. This is what's called the perception-to-action pipeline. It all happens in this continuous 5-stage loop. First, the camera captures the scene. Next, the AI instantly detects and classifies what it sees. Then, the system transforms that visual data into physical coordinates the robot can understand. The arm then executes the grasp, and finally, it sorts the object into the correct bin. And this whole cycle just repeats over and over, all in real time. And this right here really shows you the power of that detect phase. On the left, that's the raw camera feed, what you or I would see. But on the right, that's what the AI sees. Objects are instantly identified. Plastic bottle, paper cup, crushed can, you name it, all with confidence scores hitting over 95%. This digital brainpower is what drives every single physical move the robot makes. Let's break that vision part down just a little bit more. First, the system runs a quick self-test to make sure everything's ready to go. Then the camera starts streaming both color and depth data. The YOLO AI does its thing, drawing those little boxes around the objects. But step 4, that's where the real magic happens. The system fuses that 2D box with the camera's depth map to figure out a precise 3D location in space. It's literally going from pixels to a physical position. Okay, now we are getting to the absolute heart of the engineering challenge here. You know, it's one thing for an AI to know where an object is inside a digital image. It's a whole other ballgame to tell a physical robot how to actually move its arm to that exact spot in the real world. This is the incredibly tricky problem of coordinate transformation. So that leads us to the key question, right? How do you possibly bridge that gap? How does the robot translate the flat 2E pixel world of a camera into the real 3D physical space where its own arm has to operate? And this slide is where you can see the magic. It's called the eye-to-hand calibration bridge. The AI sees the world in 2D pixels, but the arm lives and moves in 3D space. This bridge is the critical process that uses depth data to translate the object's location from pixels into a precise set of 3D coordinates, telling the arm exactly where to go, what to do, and how to get there. So, to put a formal name on it, this is coordinate transformation. It is the absolute key that allows the robot's digital brain to control its physical body. It's the essential link that turns seeing something into actually doing something. Without this, the arm would just be flying blind. Of course, when you're dealing with a powerful robotic arm, safety is everything. You can't have this thing just moving around without checks and balances. And as you can see highlighted here, the system's logic doesn't just blindly follow orders. Before any movement command ever gets sent to the arm, the software runs a crucial built-in safety check to make sure the data is valid and the action is safe to perform. Okay, so we've seen the tech, which is seriously cool, but what's the so what? What does it all actually mean for us? Let's talk about the real-world impact of a system like this and how it can literally help engineer a greener future. The impact really breaks down into 3 key areas. For our communities, it means automating sorting hubs to make recycling way more efficient. For factories, it could be used to separate waste right on the production line. And, maybe most importantly, it dramatically improves worker safety by putting robots into environments that might be toxic or dangerous for people. And believe me, this is just the start. The roadmap for RecycleBot is pretty ambitious. Short term, they're looking at adding tactile sensors for a more delicate touch. Midterm, upgrading to edge intelligence to make the whole system faster and more energy efficient. And the long-term goal, a whole fleet of these robots working together in a fully integrated, smart recycling infrastructure. Ultimately, a project like this is about so much more than just code and robots. This final quote really says it all. It's about using technology to solve fundamental human problems, protecting people, making our world more efficient, and building a truly sustainable future, one piece of sorted trash at a time. It really makes you wonder, what other complex jobs could be totally revolutionized by this kind of AI vision and robotic action?